What we're going to start talking about today is we're going to talk about what's called some properties of logarithms, okay? And we know that logarithms, basically, they undo exponentials, and they have some special properties, okay? Just like we had some properties of exponents, there's going to be some properties of some logarithms, okay? So the first two I would highlight if you take notes. The first two I would get in your notes are going to be these two properties. If you have a logarithm, and these are going to work both ways, so we're going to work both backwards and forwards. If you have a multiplication statement going on, let's say this is, so we're going to say this in English, this would be log base b of m times n, okay? We can split up logs, and this is what we ended with on Wednesday. We can split this up into, or we can expand it into two logarithms, okay? And sometimes that might be helpful for us if one of these logarithms on the right simplifies nicely. And I know I'm putting this in variables right now. We'll talk about it in terms of numbers in a minute, okay? Knowing this, if we have a multiplication statement inside a logarithm, we can split it up as addition, right? We can add the two logs if we can split it up into addition. What would you guys predict we could say if I said log base b of m over n? What would your prediction be? Notice when it was
Subtraction.
multiplication. What's that?
Subtraction.
Yeah, okay. We can just write this as log base b of m minus log base b of n. That's a minus sign in there. Okay. These would be the two big ones. All right, two big ones. We'll talk about one more towards the end of class today, but these are going to be two key properties of logarithms, and we'll get a little bit of work with this. So the first one, we're going to condense it, okay? And the idea is we're going to start with three logarithms, and we're going to try to put it all into one logarithm at the end, okay? So the three logarithms we're going to look at, what if we have log of 9 plus log of 2 minus log of 3, okay? So again, our goal at the end, we want to get it all in just one logarithm. We don't want to write log 3 times. We're condensing it. We're making it smaller, okay? So if we look at our properties up here, it says, hey, if you are adding two logarithms, you can write them in one logarithm as a multiplication statement. And let me remind you, if they don't tell us anything, if they don't tell us for a log, we're going to assume it's base 10. That's the default, or that's our go-to if they don't tell us, okay? So in this case, if we combined these two, we could say, all right, this is just, we can put it into one log, and then this would be 9 times 2, okay? We're just taking these two numbers, and since it's addition in the middle, we can multiply them in one log, okay? And then we still haven't done anything with this log base 10 of 3, okay? Can you guys see what's going to happen next? What's going to happen when we have to subtract, right? This is saying we need to subtract two logs with the same base. Well, if we look up here, if you have two logarithms, they both have the same base, both base 10 here, we can write it as a division statement. So we can write this as the log base 10 of, we'll keep this guy on top, 9 times 2. And then in the bottom, just like here, you see how we had m on top, and then the second one we're going to put in the denominator, okay? And so just to simplify this, well, 9 times 2 is 18. 18 over 3 is 6. So our final answer is log, and we can put base 10, or you don't have to write it, is the log of 6, okay? That'll be our final answer there. The idea being in this case, we were condensing, we start with 3 logs, 1, 2, and 3, and we condensed it. We put it all into one logarithm there. Okay. Questions or clarifications, or can you go over that one more time? I know this is brand new, so I'm not afraid to. We're going to do a few examples here. This is still just we're a quiet group, and there's not as many of us today, so I get that. Well, let's try this then. Let's in this example up here, we condensed them. Now let's try to go the other way. This time, we're going to try to expand it, okay? We're going to expand this logarithm, okay? So we're going to have one log, and we're going to try to put it, we're going to expand it into 2 logs. So let's say we have the log of 3x to the 4th. Okay, so we have multiplication going on in here. 3 times x to the 4th. Well, if we go look at our notes, which one do you think we're going to use, the first one or the second one? Since in our problem, we had multiplication going on.
The first one with
The
addition.
first one, okay? The one that says, hey, we got some multiplication. And so the first one says, hey, if you have 2 things multiplied, m times n, you can split it up and have it as a sum or addition of logs, okay? So let's go ahead and do that. We can split this up into, so this equals the log of our first factor, log of 3, all right, plus the log of x to the 4th, okay? We just expanded it into 2 logs. In this example, neither of them simplifies super nice, so it's not like if it doesn't like log base 10 of 3 doesn't give us a whole number, but sometimes it might, okay? And then you could really simplify it into just a number there. Let's questions on that, how we expanded it. I don't want to be going too fast for anybody. So if you say, just walk through that step one more time so you can, or why did we do that? I'm fine with those questions. I encourage those questions. Okay. No? All right, let's get really tricky then. Let's say, so this will be a brand new example here, okay? We're still gonna expand just like we did above. And this time, we're gonna take the natural log. Now, natural log is just a log, I'll put it up here, a log with base e. So don't let that freak you out. E is just a number. We're gonna take the natural log of 5 divided by 12x, okay? And tell you what, I'm gonna give you a minute and a half. Go ahead and try it on your own, and then we'll come together and talk about it, just so you can get a little bit of feedback. Hey, am I doing this right, or am I on the right track? That's what this is for. All right. So what did you guys do to start? Somebody talk to me here. What'd you start with?
I did log base e.
Okay, I'm just gonna write natural log. That's fine.
And then 5
Okay.
minus natural log 12x.
Awesome. And you did that because you recognize, hey, we have division going on here, so we can write it as a subtraction statement. Good. Did anybody do anything differently? No. Head shaking. Let me draw your attention to something. What's going on here with this 12x? Isn't it 12 times x? Eliza's smiling. I think she picked up on it. Okay. So if we have 12 times x, what could we do with it? I'll rewrite this down here. So we have natural log of 5 minus, what could we do with this natural log then? Since we have multiplication 12 times x, we can write it as an addition statement, okay? That's why this one was a little bit tricky. If you got here, I'm happy. That's all right. You're picking up on what we're doing today. This one was kind of taking it up one more notch, okay? So again, if there's multiplication going on, we can write it as an addition statement, okay? And you could leave it like this, or if you decided that, hey, I want to distribute this -1 to both, you could write it as minus the natural log of 12, and we're also subtracting the natural log of x. So your final answer could be in either of these two forms right here. All right, I would take either of them. Okay. Clarifications or anything on that one? Because I know this is brand new to you guys. No?
I have a question.
Yes, sir. Go for it.
So you said the one on top would be fine, right? The one.
Yeah, if you give me this one right here, and you basically what I don't want you to do, like if you got to this step in red up here, you're on the right track. And since today's really our first day talking about it, I'm okay with it. But eventually the full answer would be this either one of these two I put in kind of the brackets.
Oh,
Yeah.
okay.
Yeah, either one of these two. Number 1 or number 2. Okay?
Yep.
Good. Good question. Okay. We'll tell you what. Our last 10 minutes, we're going to explore one new property. Okay? We're going to expand or explore one new property. So we're going to get a new page. So you guys, we talked about addition and subtraction. The only other thing that we could look at is what happens, oops, wow, it's in pen pencil mode. If we have a logarithm, okay, and we'll say log base b, and what happens if we have a power? Maybe in this case we say m to the n. This would be the other one I would definitely have written down in your notes, okay? And if we were in class, I'd probably take more time and we'd go through a mini proof of it, but I'm just gonna give you guys the punchline today. What happens is you can take this exponent and you can put it out in front of your logarithm, okay? So we're gonna put that n out in front, and then you're just left with log base b of m, okay? I don't know why it's giving me such a skinny, okay? So let's look at an example. We'll start simple here. Let's say we have log, why is it so skinny? I want a little bit thicker. Okay. Let's say we have log base, we'll say log base 5, all right, of x to the 4th. Okay. So this will be our first example here. What you can do then, let's take this exponent and we're going to put it out in front. So we could rewrite this as 4 times log base 5 of x. Okay. The exponent you can just bring down in front of the log. Or we could go the other way. If there's a number multiplied out in front of a log, you can move it up to the exponent. Okay. This statement here, it works both ways. You could either go from left to right, or if you start with this guy on the right, you could work the other way. So if you have a number multiplied out in front, you can just put it up as the exponent. Okay, you can put it up as the exponent there. So let's try this. What if we say, this will be example number 2. Okay. Let's say 2 times the log of 3, all right, minus 3 times the log of 5. Okay. Go ahead and take yeah, go ahead and take a minute and try it, and then we're gonna come and talk about it. If you don't get it right, it's our first. We're just talking about it. But go ahead and see what you can do on your own. If you get nothing else, the big things you should have, right? This was our log properties. If you have exponents, this guy right here, all right? if you have exponents in your logarithm. So I would definitely have that written down. And then the other two up here at the very beginning, all right, was if you had multiplication or division going on with logs, or adding, subtracting. Those two kind of a couple pairs there. Let's do this as our exit ticket. Just throw in the chat what was, you can either put one, you could put up to two things. What made sense today, or what do you really get, and or what is confusing still for you? Okay, because that was our big idea. So go ahead and throw that, what made sense or what is confusing for you?